All right, this is it. The last set of problems, 68 through 82. And away we go. So we're just told to factor. We're not given any specific directions, so we can kind of use whatever method we want. But based on the number of terms for this one, our option is pretty much limited to just factoring by grouping, right? So I'm going to group the first two terms together, the second two terms together, and go from there. So 2x to the fifth minus 10 x to the fourth plus 6x cubed minus 30x squared. Now let's look for what they have in common. These have a 2, right? I can take 2 out of, I can divide this by 2. I can divide this by 2, no problem. I can also divide this by x to the fourth and this by x to the fourth. I'm going to take the largest power of x out that I can. So I have 2x to the fourth coming out. That leaves me with an x minus 5. And I can always check by redistributing, make sure I get back where I started, and I believe I do. Same for here. I can take an x squared out of both of these, and I can take a 6 out of both of these. So that leaves me with plus 6x squared, and I'm left with x minus 5, which is what I was hoping, because if these are the same, now this term and this term have this binomial factor in common. So I can pull an x minus 5 out of both of those, left with 2x to the fourth plus 6x squared. Now I am not done, because these have common factors, right? And I have to factor completely. I'm not done until I factored all the way down to prime polynomials, right? So here I have an x squared in common, and I have a 2 in common. That is, this is divisible by 2, this is divisible by 2. So I'm going to pull that 2x squared out. I'm going to pull it way out to the front, leave the x minus 5 alone. And notice that when I take 2x to the fourth minus 2x squared, I'm left with x squared. And when I take 6x squared divided by 2x squared, I have a 3. Okay, now that's it. This doesn't factor any further. Yeah, double checking my work here. This gives me minus 30, minus 10. So yeah, you can always check by multiplying all of this out. It'll take a little bit, but you always can. So yeah, now it looks like we're done, right? Make sure you go till you're all the way down to the primes. There's no more factoring that can be done in a meaningful way. All right, so that's it for that one. Next one, same thing. There's 4 terms here, so factoring by grouping is probably going to be my best bet. So I'm going to group these together: x cubed plus 2x squared plus, and then I have 3x plus 6. Okay, looking at these two, it looks like a x squared can come out of both of these. So I'll pull the x squared out. I get x plus 2. And out of these, looks like I can factor a 3 out. So I pull the 3 out. I'm left again with x plus 2. Right now, the x plus 2 is in common to both of those terms. So I pull that out, and I'm left with x squared plus 3. And I'm finished, because these do not factor any farther. Okay, no sweat. Next up, more of the same. Factoring by grouping. Now I've only got 3 terms here in number 70. So factoring by grouping, I just said factoring by grouping, but factoring by grouping is not going to work. I've only got 3 terms here. So the first thing I really need to do, which in retrospect I should have done here on 68, I should have pulled the GCF out first. That would have kept me from having to factor this. I just realized that. My apologies. I'm not going to make that mistake on this one, though. Let's pull a GCF out of all 3 of these and see what we get. Looks like there's a 9 common to all the coefficients. That is, they're all divisible by 9. These are all divisible by a to the a squared, right? The smallest one will come out of all of these. Likewise, b, the third, will come out of all of these. So 9 a squared b cubed comes out of all those terms. So I'm left with a squared here when I divide this by this. Yeah, a squared. And then when I divide this by this, I should get a plus 3 a b, because a cubed divided by a squared is a to the first, b to the fourth divided by b to the third, b to the first. And then when I take this divided by this, I get negative 19 divided by 9. That should be negative 2. A squared over a squared is just 1. And then I should have b squared, because b to the fifth divided by b to the third is b to the 5 minus 3, which is b squared. Okay, now it looks like I am done. I'm actually not done. Because I can factor this using the AC method, believe it or not. It says this should look familiar to you well, it should look similar to the pattern we've seen before. But this actually factors further, because my coefficient here is 1, coefficient here is 3, coefficient here is negative 2. If I look for factors of 1 times negative 2 and add up to positive 3, do I have, maybe I don't, maybe I don't have, because this would be negative 2 and 1, this would be negative 1, 2, no, I guess I don't, so my apologies. I was thinking 2 and 1, but they would have to be a plus for that to be true, so no, but it is always worth double checking. All right, always worth double checking. You can factor again at that second stage, but it looks like this one is in fact done. Okay. Likewise here, common factors. Well, rather than distribute and then try to work backwards, let's just start here and say these, and consider this already factored, because it is already factored. Right? If I distribute, then I have to factor the 2x squared back out. So just see if, notice these two are common to both terms. So let's factor out the 2x minus 3. What's left? 2x squared plus 1. Because again, if I divide this by 2x minus 3, I'm left with the 2x squared. If I divide this by 2x minus 3, I'm just left with 1, because something divided by itself is 1. And I believe that's it for this one. But that was a one-step problem. No sweat. Okay. Next. 4 terms to this one, so factor by grouping is probably going to be the way to go. So let's go 4q minus 28 plus, and then pq minus 7p. And look at these pairwise. Looks like I can take a 4 out. So 4, that'll give me q minus 7. And here I can factor out p, so that'll be q minus 7. Now both these have a q minus 7 in common, so let's pull the q minus 7 out, left with 4 plus p, and that's it. And that is it. Not so bad. Yeah, 28 PQ. Yeah, okay. Number 73, this should look familiar because we did this in class, right? If you pull, you can pull an A out of both of these terms. So pull the A out, you have 36x squared minus 1. Now you have a couple options. You can either recognize this as a difference of squares, or you can use the AC method where your B term is 0. Just look for factors of negative 36 that add up to 0, which would be 6 and negative 6. So it works either way. I'm going to show you the difference of squares. Wait, because in the interest of time. All right, because 36 quantity squared is the same as 6x squared. Think of the square root of 36, which is 6. And think of the square root of x squared, which is x. All right, and then you take that whole product squared, and you should get back where you started. Same for 1. Square root of 1 is 1. All right, so this becomes A, and then remembering the pattern for difference of squares, you have 6x minus 1, 6x plus 1. All right, remember that difference of squares pattern. The more times you write it down, the more times you go back and reference it, look it up, the better you'll remember it. Watching me rewrite it will not help you nearly as much. Okay, next, 74 also should look familiar. This is the other difference of squares, one that really is the best way to do this one, in my opinion. right? So likewise, let's think about the square root of 1/4, right, which is 1/2. Square root of y squared is y. So this first term is really just 1/2 y quantity squared. Minus, and then same thing, this is 3/5 quantity squared. I know that because square root of 9 is 3, square root of 25 is 5. I can think of this as distributing across the fraction bar. Just remember the properties of exponents. Okay, so I have a difference of squares here, so I can jump straight to the pattern, which is plus and minus. Really is that simple. Okay, 75. Let's look for common terms, which we don't have any. Let's factor by grouping then. X squared, y squared, minus x squared, plus negative 4y squared plus 4. Okay, now what do these have in common? Looks like x squared, so I'll pull the x squared out. I get y squared minus 1. And these I'm going to take a negative out for sure, but also I can take 4 out, so I'm going to pull negative 4 out, left with y squared minus 1. Remember, because I pulled the negative out, it changes this sign. You can check by distributing if you like. Notice this will give me the negative 4, but this will give me the positive 4. I've got y squared minus 1 in common, so I'll pull the y squared minus 1 out. I get x squared minus 4 left. Now I have more work to do because this is a difference of squares. Also, this is a difference of squares. I have 2 of them. All right, so this becomes y plus 1, y minus 1, right? Because y squared, the square root of that is y. Square root of 1 is 1. Likewise for the x, this will be x plus 2 and x minus 2. Difference of squares. Square root of x squared is x. Square root of 4 is 2. And then use the plus minus. You could also use the AC method twice. That would take more time. So not that makes it wrong, but I'm not going to do it that way because time is a factor. No pun intended. All right, so that's 75. 76. Now, for these two, really, we've got no choice but the AC method. There's 3 terms, so grouping is out. And in lieu of spotting a pattern like a binomial square kind of thing, pretty much stuck with the AC method. So here, A is 6, B is negative 11, C is negative 7. A times C is 6 times negative 7, which is negative 42. Look for factors of negative 42 that add up to negative 11. And looks like this is 2 and 21, which that's not going to cut it. But what about, let's see, 4 and, no, 4 doesn't go in there. What about, we did 6 and 7, that's 13. What about, what am I missing? 42. Oh, 14 and 3. That's what I'm missing. So 3 and 14. Negative 14 and 3. You add those together, you get negative 11. Right. So now rewrite the original 6x squared, but I'm going to split that b term into plus 3x minus 14x and then minus 7. Now I got 4 terms. I can factor by grouping. 6x squared plus 3x plus negative 14x minus 7. Now I can pull 3x out. That'll give me x plus 1. No, that'll give me 2x plus 1. And then pull the negative 7 out. That will give me, again, 2x plus 1. Now I have 2x plus 1 in common, 3x minus 7 left over, and I am finished. Okay, number 77, same thing. Look first look to see if I can pull anything out of all 3 terms. Unfortunately, I cannot. 1/4 is not divisible by 5. So AC method it is. A is 5. B is negative 24, C is negative 5. A times C is 5 times negative 5, that's negative 25. I need factors of negative 25 that add up to negative 24. How about negative 25 and positive 1? So now I split the B term. I have 5x squared. This will be minus 25x plus 1x, or just x, minus 5. Factor by grouping. Pull 5x out. I'm left with x minus 5 plus x minus 5. Pull the x minus 5 out, and I have 5x plus 1. Remember that 1. Take this divided by itself, you get 1. And I am finished with that one. 77. Okay, next, more factoring fun. Now we're going to use C3 terms. The first thought should often be, apart from GCF, look for the AC method. But when you have these fractions in here, the AC method can get kind of dicey. Okay, so I would say, before we do anything, let's check to see if we have one of those trinomial perfect squares, namely this one. Not an easy pattern to spot, but it is possible. It is a potential one, right? So do we have something we can pull out of all three of these? Because as it stands, this is not a perfect square, right? It's not going to be something squared. It's close, but not quite. What happens if I pull a 3 out of all three of these terms? Well, I'll be left with x squared plus 1/2 x plus 1/16. Well, you can check by distributing that back across. Remember, 3 times 1/2, you just go straight across. 3 times 1 over 1 times 2, you get 3/2. Likewise, 3 times 1 over 1 times 16, 3/16. Okay, now we got inside these parentheses, we have this kind of setup, because if you think about it, this is x squared and this is 1/4 squared. All right, so that means A, in that case, A would be x, B would be 1/4, and 2 times A times B would be 2 times x times 1/4, which is x, 1/2 x, right? 2 times a fourth is 1/2 x. All right, so this is 2AB. So that means this is really 3x plus 1/4 quantity squared. All right, I know that's tricky, and I know that's probably the hardest one of these for anyone in the class to get their mind around. And really, the best I can tell you is look for a pattern, right? Your best candidates for these are going to be ones where if you use the AC method, you get a really, really large number that's seemingly impossible to find factors of, or you have fractions like this, right? I mean, it's a 3-term, it's a trinomial with fraction coefficients, either in all 3 spots or most of the spots. I would look for that to key in on to see if you have potentially one of these two patterns, this one or the A minus B version, right? You don't need to memorize this. You just need to remember that this means A plus B times itself and then distribute it out. Okay, next one, 79. Same thing. Let's look for something in common, right? We have to, because we don't know how to factor anything of higher than 2. Rather a degree greater than 2 that's only got 3 terms. You know that we've only talked about factoring by grouping, and then these special cases of trinomials, and all of them involve powers of 2 and below. So really, we have to try to factor something out, or we're pretty much stuck. Fortunately, all of these have a z, so let's factor the z out. Z squared minus 4z minus 12. Now we're in business, because we can do the AC method on this. Potentially, and so in that case, we would have A equals 1, B equals -4, C equals -12. So A times C is -12, and factors of -12 that add up to 4, I believe 6 and positive 2 will do the trick. So that leaves me with z squared. Let's go minus 6z plus 2z minus 12. I just split that middle term. Factor that by grouping. 2. That's why I cross my z's, because the 2's and the z's look a lot alike once you get going. All right, factor out the common term. So z, that gives me z minus 6. And then let's factor out a 2, z minus 6. And let's pull a z minus 6 out. I'm left with z times z, which is z squared plus 2. And that's it for that one. Always check by multiplying back through, if you so desire. Okay, next, 80 and 81. Look for a common factor in all three terms. We do have one, so let's pull that out. U squared plus 10u plus 25. Now, pretty much only option is the AC method. So in that case, the leading coefficient is 1. The B coefficient is 10. The constant one is 25. A times C is 1 times 25. Factors of 25, they add up to 10, 5, and 5. So let's split the middle term. And you can factor by grouping. U squared plus 5u plus 5u plus 25. Pull the common terms out. U plus 5. 5u plus 5. Pull out the u plus 5. I'm left with 2 times u plus 5. That's it for that one. No problem. That GCF at the beginning really helps. Okay, 81. Resist the urge to distribute everything, especially this, because this is not a distribution. This is 4x plus 3 times itself. Let's use substitution. Because we got 3 terms, the setup looks an awful lot like a trinomial that we're used to factoring, except to this, you have an expression instead of a simple variable. So let's go backwards. Let's let u equal 4x plus 3. That's the case, then we have instead u squared minus 12u plus 36. And A would be 1, B would be negative 12, C would be 36. AC would also be 36, and we have negative 6 plus negative 6 would give us negative 12 multiplied together to give us positive 36. You can use the negative versions of those when you need to. So you'd have this be u squared minus 6u plus 36. And once you factor by grouping, pull the u out, you get u minus 6. Pull the negative 6 out, you get u minus 6 again. U minus 6, u minus 6. Well, you know that looks an awful lot like u minus 6 quantity squared, but actually I'm going to leave it as this because I have to unsubstitute now, because u is really 4x plus 3. And I'm subtracting 6. I don't need parentheses for that. This is really 4x plus 4x minus 3. I'm going to write that as 4x minus 3 quantity. So actually, no, I'm going to distribute this out. That'll give me 16x squared, and that will be minus 12 minus 24x plus 9. This is really what you want. No, it's not. Sorry, guys. So what happens, you start factoring and then you shift gears and try to multiply it. I want this written as a product of factors. Got myself turned around. I want to leave it with factors. I don't want to multiply again. Just the same reason why I didn't multiply this back out. Okay, 4x minus 3 quantity squared. All right, last one. Same thing. We're going to factor by substitution. That really is our best bet. So I'm going to let u equal 3t plus 5. This becomes 4u squared plus 2u minus 2. Looks like AC is the way to go. This is 4. This is 2. This is negative 2. A times C is going to be negative 8. And I can use 4 and negative 2. Add together, give me positive 2, which is what I want. Okay, so this will be 4u squared plus 4u minus 2u minus 2. Factor by grouping. Pull the 4u out of the first one. That gives me u plus 1. Pull the minus 2 out. That gives me u plus 1 again. Pull the u plus 1 out. U plus 1. 4u minus 2. And then plug back in 3t plus 5 plus 1. 3t plus 5 minus 2. Let's clean this up. 3t plus 6. Okay, I do have to distribute here. So that will be 12t plus 20 minus 2. This will be 3t plus 6. 12t plus 18. Common factors, yes, there are. I have a 3 I can pull out. That's t plus 3. And I have a 6 I can pull out, which would be t plus 3. Which, now remember, I don't have a plus here. So it's not about factoring this out. It's about rearranging, right? It's about combining. I have 3 times this times 6 times that thing again. I'm going to rearrange. That's 3 times 6 times t plus 3 times itself, which I can write as 18 t plus 3 quantity squared. Right, as opposed to here where I just factored the same one out and then I'm left with these coefficients. That's not what's happening here. This is not a plus or a minus in between. This is just the product of 4 things, and I can just rearrange those 4 things, but I have to keep it as a product. All right, this no longer means this now means this times itself, this squared. Okay, so read that very carefully. Make sure you get that straight in your mind. All right, folks, that's it. That's the last problem in the review. Best of luck to you all. Email us if you have questions.